you're able to complete your work together. Leo, I
Yep.
think we have a lot of people on now, so you can get started. Welcome, everyone.
Hello, guys. It's amazing to see your beautiful faces one more time. I see my wonderful friends here. I see Kalua. Before already spoken to Wadi. I see Abdul Rahman again. I see Machi. I mean, mentioning your name is always difficult for me. Matt, she, Diso. If you could unmute yourself and then mention it for me, I'll be very happy. Because I always struggle mentioning that. I see Ikwebe as well.
Okay, you did well.
I did was. And I see Mohammed. You guys are welcome. You're welcome. We're going to have a blast today. And we're not going to waste a lot of time trying to go through the initial concepts, which you've already done. We'll try and handle the core concepts of the Printf project itself. And hopefully, by the time we are through, we should come to a place where you're at least comfortable to handle the first, second, third, fourth, kind of maybe fifth task. And we have about 45 minutes to be able to do all that, and also allocate some time for questions and answers. Okay. So without wasting any more time, I'm just going to go ahead and share my screen. Okay. So today, we're going to be handling these 5 things that you see here. We're going to be talking about briefly what it means to parse a string, how to write to the standard output without printf. We're going to also talk about how to create a local buffer, because it's one of the requirements of the project. We're also going to talk about how to handle the files. How do you even manage the files? How do you arrange the files? What goes into which file? All right, we're going to talk about that. And then we're finally going to talk about how to break the code into different files for different format specifiers. Basically, these are the things that we're going to handle today. So the first thing I want us to get to is string parsing. Now, when I'm explaining and you get to a point where you don't understand anything, Abena is on the watch, so you can just raise your hand and she's going to just notify me, and you're going to unmute yourself and ask any question that you want to ask. But we're going to use about the first 15 to 20 minutes to rush through some very critical concepts that I want you to get. And we're going to use the rest of the time to take care of any issue that you might be facing. So let's get straight to string parsing. Okay, what is string parsing? For you to create a Printf project, a Printf function, what the function does is that it takes a format string and then prints the format string to the standard output. I'm sure on the research that you guys have done, at least you have a fair idea of what the printf function does now. We are not going to waste our time talking about the functionalities of the printf function itself. Now we want to focus on how to implement the printf function itself. Okay, so when we are done with the session, I'm going to share this slide, and in addition to what we did in the first session with you guys. And then you guys are going to have at least everything. So I'm not going to waste a lot of time reading through the contents of our slide. Let's talk about string parsing. Okay, what is string parsing? Whenever you give a function to printf, this is what happens. The printf function takes whatever string you give to it. Let's say I give this string Mohammed. Okay. I just hope I have the spelling of your name right still. Okay. Because this is a custom printf, I'm going to bring an underscore here. Now, this is what the compiler does. Whenever you give, let's say, something like a string to the compiler, it takes the string one at a time and then inspects to see if it is a usual character or if it is a format specifier. So the compiler now comes and checks what is an M. It's a usual character, so it takes it to the standard output. What is an O? A usual character. What is an H? A usual character. So the compiler is going to run through the entire string and then inspect to see if there are any special characters in here. If there are no special characters, then it is immediately going to print everything to the standard output. So you're going to have this printed in your terminal. Okay, that is very simple and straight to the point. So when we talk about string parsing, that is what we are referring to. But sometimes you realize that certain format strings that you give to the compiler contains special characters. So for instance, I can say something like Matitiso. I cannot pronounce your I'm not gonna write your entire name, but I'm gonna shorten it to MAT. All right, because that's all I can do for now. So Matt. So I'm gonna say something like Matt is %. Okay. So I'm going to pass this format string to the compiler. And what the compiler does is that it's going to take the format string one character at a time. So I'm going to take the M. What is it? It's the usual character. So I write it to the standard output. I'm going to take the A. I'm going to take the T. I'm going to take everything until I come to a special character, which is the percent sign. The moment the compiler sees the percent sign, it takes a pause because it knows that the user of the computer is about to give it an instruction. So this is a directive. The moment the compiler sees the percent sign, it knows that I'm about to receive a directive. So that means that the next thing I need to do is to check the next character. And then whether I see an S, whether I see a C, whether I see a D, whether I see an X, or whatever I see, that is what will determine what the compiler will do. So basically, this is what string parsing is. So the compiler now comes and then prints the usual characters. And then in place of the special character, it now goes to search all the list of arguments. Okay, it goes to search all the list of arguments that you have given to the compiler, and then it replaces the arguments that you said it should give to the percent s. Let's say math is here. Okay, so the compiler now takes this percent s and replaces it with math is here. So you're gonna have this printed on the standard output or your terminal. This is very simple and straight to the point. So how does this apply to Printf? Okay, let's go find out how this applies to Printf. Now, before anything will be printed to the standard output, there are functions that carry your string or your format string to the standard output. One of the cardinal functions that does that is the printf function. Okay, so now I can come into my code and I'll say that printf, because it's a custom printer, let me put the underscore here. I want to print something like Abena. Okay, so Abena, printf is going to take Abena, the string Abena, to the standard output. Okay, this much we know. We already know what the printf function does. But here in the case, in this project that you have been given, ALX says that there are certain required functions that you are supposed to use. All right, and printf is not one of them. If you look at the allowed functions that you are supposed to use, you are supposed to use write, malloc, free, va start, va copy, va argument, meaning that you cannot use the printf function to write text to the standard output. And there are several functions that you can use to write text to the standard output. However, remember that it's a project that you are doing, so you have to try as much as possible to follow the requirements. So the authorized functions and macros that were given for this project is write, malloc, and the others. Now this simply means that we have to search through these functions and macros and find out that which one can write text to the standard output. Now when we look through this, we already know which one of them can write text to the standard output. And it's simply the write function. I'm sure you guys are familiar with it. And the reason why I think you're familiar with it is because of the putchar. Remember in the earlier project, ALX will tell you that do not use printf, use putchar. But the problem with putchar is that putchar only prints a single character to the standard output. So if you use putchar, you have to keep looping and looping before you can print a string or anything else. And also you have to keep them doing an ASCII conversion to use putchar. But the write function is very easy to use, and that is why I'm sure ALX allowed us to use the write function. Okay, so there are other functions that you can use to print text to the standard output, such as fputs or putchar. But here in this case, we've been told to stick to the write function according to the requirements of the project. So the question that we need to ask ourselves then is, how is the write function used? How can I use the write function to output text to the standard output? Because that is what you are going to use to implement your printf function. You're going to use it to write text to the standard output. That is very critical to understand. I hope I can proceed from this point. So is there any question to this point, so I should go on? If there are no questions, you can just lift a hand or something in the chat box. You can just show a reaction or something. There's no question, so that I can just proceed. Just one person. Oh, I see Miriam here. Miriam, you're welcome. I was watching your video the last time. I was very, very happy. Welcome, Miriam. Okay, so I'm going to go right on. how do we use the write function? Okay, now the write function works in a very easy way. First of all, you need a syntax write. All right, write. Then I'm going to break down what you see over here. It is not confusing at all. It is very simple and straight to the point. Okay, for you to create a write text to the standard output using the write function, the first thing that you need to do is to bring your write keyword. Then the write function contains three main things: 1, 2, 3. Okay, the first aspect of the write function is a file descriptor that takes your text or your content to the standard output. And then the keyword for that file descriptor is the figure 1. Okay, so whenever you see the write function and it is being used to take text to the standard output, the figure you are going to see is 1. It is always that way, all right? Because the figure that represents the standard output in the file descriptor is 1. It is very simple. Just keep it in your mind and use it this way all the time. Then the next thing that the write function takes is the address of the variable or the string that you're trying to take to the standard output. So I can see the address of whatever variable this is. It could be any name, right? And the final thing that the write function takes is the size. The size or the size of the value of the variable. So here in this case, you're about to allocate a number of bytes to the function. Assume I want to print a single character like M for Miriam, to the standard output. Because M is a single character, I'm going to allocate just 1 byte. Assume I want to print, is it Mariam or Miriam? Let me go check the spelling carefully. It is Mariam. Okay, so assuming I wanted to print Mariam to the standard output, and I'm going to count 1, 2, 3, 4, 5, 6. So I'm going to allocate 6 bytes to print this string to the standard output. That is very simple and straight to the point. Okay, so now assuming I want to print an entire passage, like the story of my life, maybe the day when it was raining that I fell into a gutter, I want to print that entire passage to the standard output. How am I now going to count every character in a string to now come and allocate the memory that the write function is going to use? No, there's no way I can do that. But then the easy way by which I can implement that is to use the function that calculates the length of the string. And if you have gone through the string formatting options, so you know that one of the functions of the string h header file that calculates the length of a string is a string length function. Very simple, very simple. We're going to use the string length function to calculate the length of whatever string or format here. And that is what we'll use to allocate memory for the write function to use. So guys, this is it about the write function. It's very simple and straight to the point. The standard output, the name of the variable or the address of the variable, then memory, the size that you are allocating to the memory. This is it about the write function. Very, very simple and straight to the point. Okay. However, before you use the write function, you have to include the Unix standard header file. So you're going to include the Unix standard header file. All right, that is very simple. Anytime you're going to call the write function, you should know that this should go into your main.h or your header file. That is very simple and straight to the point. Now let's go into more technical stuff. All what I explained, I'm very sure you guys are already familiar with it, and then at least you can find your feet around it. But this is really where I need your attention, because without this, you will not be able to answer some of the later tasks. I'm about to teach you how to use a local buffer and then allocate that buffer to your functions, so that whenever text is about to be taken to the standard output, you first go to a temporal buffer, then that buffer gets full before we take it to the standard. If you don't understand what I just said, just take your time. I'm going to break it down further. Okay. At this juncture, taking a deep breath, empty the breath, taking a deep breath and relax, because it's very simple and straight to the point. Okay. Now, one of the requirements see that the earlier presentation that I did, I was just rushing through because you're at least a little familiar, but now I want to take my time. Okay. In one of the requirements of the project, ALX asks us to use a local buffer of 1024. Okay. If you look at task 4, it says that use a local buffer of 1024 characters in order to call write as little as possible. Now I want you to pay attention. With the initial task, you are just supposed to write the code for the conversion specifiers. Then basically that's it. You're not even supposed to handle the weight, precision, and others yet. All right. So the conversion specifiers that you have already implemented for task 0 and 1. Now we are about to use a buffer to hold any value that your string has before we take that to the standard output. This is what I'm talking about. Stay with me. Okay. I already explained to you that when a string is being parsed, first, the compiler checks it character by character and takes it to the standard output. And then we came down here to understand that for the compiler to take the characters one by one to the standard output, it uses the write function, because that is what we are permitted to use. All right. Now, further, we need to understand that ALX is saying that they don't want a write function to be called over and over and over and over and over and over and over. So we need to use a local buffer of 1024. Let me go take somebody's name and I'll use that to explain something to you. I see Ayad over here. Let's say I want to printf Ayad. Okay, now when the compiler is working, just like before we already understood, the compiler will take the I and then use the write function, take it to the standard output. The compiler will now come back, take Y, and use the write function to take it to the standard output. The compiler will now come and take A, all right, and use the write function and take it to the standard output. So assuming you are printing a string of the story of my life, all right, and it's an entire passage, the write function is going to be called for each and every single character. So if you are printing an entire passage, imagine the number of times the write function is going to be going and coming. Right. So basically, the buffer that ALX is talking about is supposed to be like a container, right? So listen to this carefully. Instead of calling the write function to take our string, our format string, character by character to the standard output one by one. Now we're not going to do that anymore because our write function is going to get tired. So we are going to create a container. We are going to call this container our buffer container. Okay. So just like I was saying, instead of using the write function to write the text to the standard output character by character, we are now going to create a container so that when we are going to print Ayad is handsome. Okay, we're going to print Ayad is handsome. So we are not now going to come I write to take it to the standard output, Y write to take it to the standard output. No, write is going to get tired. Our write function is going to get tired. So this is what we're going to do. We'll now take the I. Now we want to print it to the standard output, but we'll not take it there yet. Okay, we'll bring the I and store it in this container. See, the next one, Y. So we are going to keep bringing our format string. Ayad is handsome. We are storing everything in this buffer container. This buffer container that we have created. Okay, and the buffer has a capacity of 1024 according to the requirements that we were given. It says that our buffer should, our local buffer should have a capacity of 124 characters. All right. So what's going to happen is that our format string can be stored in the buffer container. So like there's so much content can be stored in the buffer container until the buffer is full. and the capacity of the buffer is 1024 characters. So when the buffer is full, they will now bring the entire content of the buffer and print it to the standard output, and then you see the text on your terminal. So in this case, what happens is that in the first case, I had a handsome. So the write function was going to work 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 times. All right, the write function was going to work 14 times. But here in this buffer case, the write function is going to work just once. So now we are not going to be calling the write function so many times for each character. Now we store the characters in a container or in a buffer. Then when our container is full, that is the capacity of 1024 characters, then we'll take everything to the standard output at one time. That is very simple and straight to the point. And this is basically what task 4 is asking for. And for you to implement, I'm going to show you in pseudocode actually how to do this. All right, I'm going to show you in pseudocode how to do it. But for you to implement this, it's going to affect every part of your code. So if you have already written a code, some people were coming to me and then their challenge was that I've written everything according to the requirements of the project. But then when I check, I'm still having read an error in the code. And yet it looks like I've done everything. This buffer I'm talking about may be the reason for some of the reds that you are seeing in your code, because you have to define a buffer of 1024 characters. Until you define that buffer, you may not have everything checking. Okay, and there is a reason why. Because the moment you now start defining the buffer, it will affect the rest of your code. You may have written the code already, but everything will be affected again. And I'm going to show you why I'm saying this. How many minutes have we done so far? We started, so we've done about, let's say, 24 minutes. Okay, that is good. So let's go find out in pseudocode how to implement this buffer and how to use that to refine our code. So now what we're about to do now is that we're about to refine our code. Okay, we are refining our code. Now listen to this. The buffer is an array of characters used to temporarily store the output before writing it to the standard output. Then, for you to define a buffer, you first have to define the buffer size, which we have already been given. Then we are going to create a variable to track the buffer index. When the buffer is full, we are going to write it to the standard output. That is what I just explained to you right now. We are not going to add format specifiers directly to the buffer. What we'll do is that we are going to call a separate function, okay, to handle the format specifiers. Then we'll add a result to the buffer. But if it is a character, we just add it straight to the buffer until the buffer is full. But if it is a format specifier, then we'll call another function to handle that format specifier before we take it to the buffer container. If you are confused about what I'm saying, take your time. I'm going to break it down with diagrams, okay? So you're going to understand it. Let's go back to the sketchboard to understand everything that I just read, okay? Now we are going to print Bongane, all right? So Bongane smart, okay? But I'm not going to print a smart here. I'm going to replace it with a format specifier %s, which prints a string, okay? So now my buffer is going to work in such a fashion. You already know all these are just usual characters, so they'll be taken to a buffer container, okay? So Bongane will be printed. Then now the compiler comes across a special character %s. This %s is not going to be directly written into the buffer. No. All right. What is going to happen is that we are going to call the elder brother of the compiler, okay? And we are going to give this %s to the elder brother of the compiler, and the compiler is going to decrypt. It's going to decrypt this %s. Then we are going to decrypt this %s and find out that it's an argument of the word smart. Then when we decrypt it, then we'll now bring it into the buffer. So then we are going to have Bongani is smart. I hope that is very clear. What I'm just demonstrating to you right now is how you are going to write your code. Okay, what I just showed you is how you are going to write your code. So this is what's going to happen. I have my printf.c file. Instead of writing all my functions in the printf.c file, which you can actually do, you can have a code of 100,000 lines. No. This time around, what we are going to do is that we are going to modularize our code. We are going to modularize our code. All right. So this elder brother of the compiler that I'm talking about, we're going to break our code into several files. Okay. So now our first prototype of the printf function is going to be, we already know that this is our prototype. So it's a constant. It is a character pointer. Then we have our format. Okay. Then our parameters. Sorry. This. So I've not brought a data type. So I'm going to say int. This is the name of my function, printf. Then the first parameter of the printf function is the format string. Just like I showed you. Then int character is a format string. Then it is a variadic function, so it is represented by 3 dots. Okay, so inside my printf.c file, I brought my prototype. I'm about to write my code for the printf.c file. Okay. Now, I'm going to have several other functions. Now, listen to me carefully. Listen to me carefully. I'm going to have several other functions that are going to take care of various aspects of the printf function. These are the brothers and sisters of the printf.c file. Each of this file will handle a certain functionality of the printf function. So this is what will determine which files are created and what will be inside those files. I hope that is very clear. We're going to do it now. Let's write our printf function. So now I know that I have to handle a format specifier. Let's say %s. You can either decide to put all the format specifiers in one big file, or you can separate them into several files. And I'm going to show you how to do that. I can put another functionality %c in another file. I can put another functionality %d in another file. Then here in my printf function, this is what's going to contain the main variadic function that's going to be calling the other functions in the other files. Okay. This simply means that what's going to happen is that since all this code is in separate files, we need to find a way of connecting all of them. We need to find a way of connecting all these plenty files that we're about to create that will contain separate functionalities into one big family. All right. And that is the purpose of the main .h header file. Okay. So now I'm going to create a functionality.
Hi, Mr. Leonard. Someone muted you.
Oh.
Well, you can hear you.
Oh, sorry. Can you hear me?
Yes.
Yeah. Where did you lose me? At which point did you lose me?
Just a few seconds.
So you were
connecting the file.
Okay, I was connecting the files. So this is the purpose of the main.h file. So this printf function that we have created up here, the prototype of this function will come here. So the prototype of printf will come here. And if I create a function that handles this %c, the prototype will come into main.h. If I create a function that handles this, the prototype will come here. If I create a file that handles this, the prototype. So the main.h file becomes the glue. The main.h file is a glue that is going to hold all our files together. Then now when the compiler is working, they can go to the %d file, go and pick a function and come and use it. They will go to the %x file, go and pick a function and come and use it. It will go to the precision file, pick a function and come and use it. It will go to the width or length modifier file, go and pick a function and come and use it in the printf.c file. If everything I said has become plenty, now I'm about to break everything down. Finally. Okay. I think I've broken things down like 1,000 times already. All right. So now let's actually code our printf function. So this is our printf.c file. We're about to code a printf function. What do you do first? You include, as usual, your main.h. Okay. You must include main.h in all the other files you create. And I've already explained to you that the main.h file is the glue that holds all the other files together. So everything you do, you must include your main.h file. So because main.h is so important, I'm going to put that file here. So this is main.h. Then inside the main.h, because the compiler is going to keep calling main.h over and over and over in all the files, we need to include an inclusion guard. I'm sure you guys know about it. So if not defined, we add a macro main _h. And we're going to see that, sorry, my pencil is acting now. And we're going to see that define main _h. Then at the end of the day, we're going to see that and if. Then the prototype of all our functions and our header files are all going to come inside this main.h file. I hope that is very clear. Over here in our printf.c file, we're going to include our main.h file, quotation marks, because it's a custom file. Then the next thing we're going to do is that we're going to bring our prototype of the printf function. Okay, so we bring our printf prototype. So the prototype of printf. Okay. Now the reason why I'm showing this is that I want to teach you how to implement the buffer and use the buffer to refine the rest of the code. Okay, that is why I have to take my time and pseudocode you through the entire process. Okay, so now I've included a prototype of my function printf. The next thing you want to do is to probably declare some variables that will hold a few things. But before that, remember that you're about to use the buffer that I spoke about. So you have to define the buffer according to the requirements that were given in the project, according to the size. And how do you do that? I already explained to you in the slide that to define a buffer, you use the syntax define buffer size, which is like a variable. Then you bring the size of the buffer. Okay, so now in our main.h file, which contains all our header files and prototypes and everything, we're going to define the buffer in our main.h file. So over here, we'll come and say we want to define a buffer size of 1024. Okay, so inside the code, whenever the code comes across the buffer size, it immediately knows that we are dealing with a buffer size of 1024 and to never go beyond that. Okay, so right here, we're just going to come, let's declare maybe a variable. We're going to see that our buffer, remember I've explained the buffer to you, is up there. The buffer is the container. We're going to see that our buffer will be equal to buffer, which will hold the buffer size. I just hope I have the syntax right. Let me refer to my notes. Let's see. No, I don't have the syntax right. So let's work on it properly. So I'm going to clean this. That's not the proper syntax. So our buffer, our buffer is definitely a format string. So it's a character data type. Okay. So our buffer is going to be, this is the name, like we are declaring a format string. Now we have created a container that's going to hold all our characters temporarily before we take it to the standard output. So now we are going to declare a format string that will hold our buffer temporarily. And then the buffer size, which we have already going to define in our main.h file, is 1024. So in the mind of the compiler, whenever it sees buffer size, it's going to replace it with the value 1024. Okay, that is very simple. So that should represent in your printf function. So now we have defined a variable buffer, and we have given the buffer the size, the amount of characters that it can hold. Okay, the moment we are done with that, now we have to define another variable that is going to track the index of this buffer. What do I mean by that? Let's just back up a little bit. All right, let's go to our container. If anyone wants to ask a question, I'll pause for like a second and you can just tip it in. Or if you If you don't mind, I could also go on. Finish it up. Open for questions. Any question?
Yeah, we could put some questions if they're available. They are running like in time. We have about 12 minutes. I think there's another session happening at 4 p.m. Last year. Yeah. And the recording and the files will be available, so not worry.
So should I go on? There are questions. Looks like everybody wants me to go on because they want to know what's going to happen. Okay, so this buffer is supposed to track the number of characters. So assuming we are about to print Ayad is handsome. Assuming we are printed I, then the buffer is now at index 0. Then we'll come to Y, index 1, A, index 2, D, index 3. So we need to create another variable that's going to be tracking this index or the buffer. Okay, so now in our printf.c file, we'll definitely come and create a variable, something like, let's say, a buffer index. Okay, and we're going to initialize it at 0. And this is what's going to be used to track the buffer, the container that will be holding the characters that we are storing temporarily before we take it to the standard output. That is very simple and clear. Then now you now come and use variadic functions to extract the various arguments. And I'm sure you are a little familiar with that. So now the next thing you want to do is that so you're going to say that if your string, your format is a wrong format, let's say someone enters a string which is null, then you want to print error to the standard output. You remember the syntax for an error, simply -1. This is the printf file that you're writing, okay? You now also want to come and say that if your string is the null character, then quit the program, okay? Then you now come and say that if your string is not this sign, because remember I explained to you that the compiler is going through it character by character and inspecting to see if it's going to find a special character, okay? So it's checking through the usual characters and boom, it hits a special character. So you're going to say that if your string is not this %, then we are going to take whatever iteration it is. So whatever this is, we're going to keep it in the buffer variable. I hope that is very clear. Remember, we have created a buffer container that's supposed to hold the values that we are parsing, If we check and it's not the %, and let's say it is the sign W, so we are going to keep it in our buffer container. So we're going to say something like our buffer, just give a moment. Yes, our buffer, whatever index it is currently at, so our buffer index will be equal to our string or our format. Okay, so whatever character the compiler is going to come across, it could be W, it could be B. I think B is a special character. Let me find some. It could be A. We are printing just usual strings. So if it is not a %, then we are going to store the value of that string in a buffer variable. Okay. Now, if we now encounter, if our format now encounters the %, then what is it supposed to do? So now we are parsing our strings. We have encountered the %. You have now come and hit on the %. You have to give an instruction in your code that when you hit the %, the next thing I want you to do is to check the next character. So we are going to tell our compiler that when you hit the %, check what is the next character. Okay, so we are going to check the next character. So you can simply increment it. All right. Now, when you check the next character and it is that, this is where you now come to the implementation of the format specifiers. Okay. Now, if you check the next character and it is maybe a C, what should you do? If you check the next character and it is an S, if you check the next and it is a %, if you check the next and it is a D, if you check the next and it is an X, what should you do? what you do if you encounter a special character. So you are going to say that, now you know that all these are going to be in either an if-else statement or a switch statement. All that is dependent on you. But because I'm pseudo coding, I'm not really taking my time with the syntax. But I want you to get a fair idea of what is happening here, right? So I'm going to say that now that our format is the percent sign, it has hit the percent sign, and we are checking to see what is the next character. So now we are going to call a new function. Now listen to this carefully. We are going to call a new function to handle each of the format specifiers. So let's say in one of my files, let's say I have a file that's going to handle the %d. Okay, so let me create that file here. Else, I've created a new file here. Okay, I'm going to call it handle integer C. Okay, now inside this my integer.c file, you know that I have to include my main.h. No doubt about that. All right. Then now I come and create a function. All right, I come and create a function, maybe int handle integer. Then inside that function, I'm going to put all the parameters of the variadic function that is going to be used to extract the arguments of the integer. So inside this file, I can now come and say the parameters are going to be like arg, list. I can have a parameter of an integer. I can have several parameters of the function that I created called handle integer. Then in my printf.c file, I'll now come and see that, remember that we are at the point where the compiler has encountered the percent sign and is checking to see what the next character is. So assuming we check the next character, and let's say the character is a D, that means that it's supposed to handle the code logic that prints an integer to the standard output. And we have come to put that code logic in this handle integer.c file. So all we have to do here is that we're going to tell the compiler that else if you encounter a special character, now else if you encounter a D or a C or an X or whatever format specifier it is, or an S or whatever. At this point, like the code logic is in your hands. You can do whatever you want to do with it. All right, you can do whatever you want. You can either decide to handle them one after the other, one after the other. You can put all of them together, because you can even separate them into several files. So over here, you can say something like, if the next character you are encountering is a D, then I'm going to call the function that handles the D format specifier. Assuming I put everything together, then that means that I'm creating a file that's going to handle all the conversion specifiers at the same time. So all my conversion specifiers will go into one file, assuming I put everything together. So inside this file, the logic that handles %d will be in it, %c, %x, %o, %p, all the format specifiers will be in this, assuming I decide to put everything together. But let's say I don't want to do that. I want to break them into separate files. So I'll now cancel all this, and I'll see that else if the next character you encounter is a D, then I'm going to call the integer function. So I'm going to say that handle int. Then I pass in the argument with variadic argument. Then I extract whatever argument there is. Okay. Then I now come and see that else if you encounter the character and it is a C, then I'm going to call the function, which I'll put in another file. Okay, let's say I've named this file handle character.c. Okay, then I'll now come and call this function that else if the character is a C, and I'm going to call the function handle character function. The handle character function is in this file. I'll call the handle character function, and I'll use the variadic argument to extract whatever argument there is in it. All right. So you're just gonna go like that until you handle all the format specifiers. I can come again and say that else if my character is an S, then I can create another file called string.c. Then the code logic that handles a string is gonna be in this file. and I'm going to call, let's see, the name of the function in this file is handle string. So here I'm going to call the handle string function, say handle string. Then I'm going to pass in the variadic arguments to extract the arguments of the string. But don't forget that when you are handling the string function inside this file, you are supposed to also implement a logic that will calculate the length of the string. So string len, and then you pass in your formats. Okay. Then now, this is where things get critical. At every point, when you are done calling your function over here, remember that you are supposed to store all your variables in a buffer. Okay. So over here, any function that you call, now the output of the function is supposed to be stored in the buffer. They're going to see that your buffer, whatever the buffer index is at currently, so your buffer index, now you're going to store the format in your buffer index. So you're going to keep storing things in your buffer index, and right after the buffer, you're going to see that if at a point when the buffer gets full, so if your buffer index, you get to the point where your buffer index becomes the same as your buffer size, which we have already defined as 1024. When the buffer becomes full, so your buffer index becomes the same as your buffer size, then the next thing you want to do is to now empty the buffer to the standard output. So we are going to call the write function. We're going to tell the write function to write to the standard output. What are we writing to the standard output? We are writing our buffer to the standard output. What is the size that we allocate to the write function? Our buffer index. Because at that point, the buffer index is the same as the buffer size. Like the buffer is full, the container is full. So let's go and empty it at the standard output. So now, whenever you now give your format to the buffer, right beneath it, you want to now indicate that if the buffer is full, take it to the standard output. All right. And at the end of the day, the final code that you're going to write is that in your Printf.c file, that if at the end of the day you have taken care of all your format specifiers and your buffer still has a figure, let's say your buffer index is still greater than 0, which means that there's content in the buffer, then now you want to write whatever content is in it to the standard output. Now you're writing your format to the standard output, and then the amount of memory you allocate to that buffer will be the buffer index. This is what's going on.
Oh, clear.
Yep.
Yeah, I hope they are just about wrapping up.
Actually, this is the final thing that you have to do. So basically, I know it was a long code, and actually, to implement all the format specifiers and everything, this is what you need to do. What I'm going to do is that this notebook, I'm going to share this notebook on the Slack page, in addition to the slides and the resources. Okay, then you can take your time, and then at least it's a mess. I know it's a mess, but you can take your time and then look at the logic and try and write your code, modularize it. If you have any question, we are always on the Slack channel to help you out. Okay, so at this juncture, I think I'll bring my presentation to an end. There was a lot more that I needed to share to help you modularize your code, but I think 1 hour is a short time for us to handle everything. So if you have any question, you can go ahead and ask. We're out of time. Abena just sent me a message at time. All right.
Yeah, so I think for further questions, you can just include in the class, or you can always use the A16 tag, or you can always just tag or DM myself and do that for any further assistance. I hope this has been very insightful. And yes, yeah, I think this wrap up it.
Yeah, I mean, so that is it. I've now said everything, including. So I think we'll just call it a day. If you have any questions, you can always put it in Slack. I prefer you make it public so that other people may have the same question, so that they could also benefit from the question.
Yeah.
So I've been out over.
For that,
Over to you.
Yeah, I'll just say thank you for that. You know what? Happy code. Producer Kelly.